basic understanding of combustion is fundamental to a broader study of wildland fire behavior. Combustion can be defined simply as the process of burning. Understanding the process of combustion and how heat is transferred is important in understanding wildland fire behavior. How fast fire spreads, how much heat is put off, and how big the flames are all depend on the process of combustion. The process of combustion is independent of scale and dictates everything from your ability to roast a marshmallow over a campfire to the spread of crown fire across a landscape. The phases of combustion and how heat is transferred can also relate to whether the roots of the plants in the soil are damaged or whether the crowns of trees are scorched and turn orange. Combustion and heat transfer form the building blocks to understanding wildland fire behavior and effects. The chemical process of combustion is shown here in its basic form. The inputs are basic sugars, which are formed during photosynthesis and are the building blocks of plants. Oxygen and an ignition source. As combustion proceeds, carbon dioxide, water, and heat are released. This is the same process as decomposition, but combustion is much faster. This is the exact opposite of photosynthesis, the process by which plant material is created. Plants use carbon dioxide, water, and solar energy to produce basic sugars, which form the building blocks of all plant material. Oxygen is released in the process. This process is essentially reversed through decay or combustion. The fire fundamentals triangle, shown here, is used to describe the factors necessary for combustion. All three legs of this triangle, heat, oxygen, and fuel, must be present in order for combustion to occur. In the case of wildland fire, fuel comes in the form of living and dead plant matter like shrubs, trees, litter, and woody debris. Oxygen comes from the atmosphere, and heat comes from an ignition source such as lightning. If all three legs of the fire fundamentals triangle are present, the fuel is ignited, and it can become a source of heat for other fuels. This is what we call heat transfer, and it is necessary for fire to spread. There are three basic mechanisms for heat transfer. One is conduction, which is defined as heat transfer by molecular activity. Through conduction, heat can be transferred from one part of a substance to another, or it can be transferred between substances that are in direct contact. For example, when a pan is on a hot stove, heat is transferred from the bottom of the pan to the handle via conduction. Different substances conduct heat differently. For example, air and wood are relatively poor conductors of heat, while metal is a good conductor of heat. This is why you would get burned if you were to touch the handle of this pan. In wildland fire, conduction is the primary mode by which heat is transferred within fuel materials. For example, heat from this flame will be transferred to the rest of this log through conduction, which will dry out the fuel and raise its temperature, making it more susceptible to combustion. Convection is another form of heat transfer, and it is defined as heat transfer by movement of liquid or gas. The flames that you see in any fire are produced from gases that are ignited during combustion, and thus are examples of convection. You can see this as you look closely at a burning match. As the match heats up, the wood breaks down and produces volatile gases. The ignition of these gases is what produces a flame. Convection would also be responsible for the heat you feel when holding your hand over the match but not touching the flame. Convection can also be important in wildland fire, as the hot air currents produced from fire can be responsible for preheating tree crowns and higher shrub layers, making those fuels more susceptible to combustion. Thus, convection plays a large role in the transition of the fire on the surface into the crowns of the trees above. Fire also spreads uphill faster due to convection. The convective heat from the flames preheats the vegetation up the slope, dries out the fuels, and makes them more susceptible to ignition from the advancing flame. The final mode of heat transfer is radiation, which is defined as transfer of heat energy via electromagnetic waves. The heat that reaches the Earth from the sun, for example, is transferred by radiant energy. The amount of radiant energy you feel from fire or any substance is a function of the temperature of the fire and how close you are to the fire. The hotter the fire and the closer you are to it, the more radiant energy you will feel. Radiant energy also plays a role in preheating fuels ahead of the fire. Because of radiant heat, Firefighters can be injured from fire even when they don't touch a flame. Just as you can get sunburn from standing in the sun, you can get burned from standing too close to a hot fire. To summarize, combustion is the opposite of photosynthesis. It is a chemical reaction that uses the basic building blocks of plants, oxygen, and an ignition source to create carbon dioxide, water, and heat. The inputs of this reaction are all represented in the fire fundamentals triangle as fuel, oxygen, and heat. Heat transfer is important in understanding how fire will move and behave. Heat is transferred through conduction, convection, and radiation. All three heat transfer methods play a role in wildland fire through preheating fuels and preparing them to burn. In the next video, you will learn more about the 4 phases of combustion and how preheating fuels is critical for fire to spread.